Let's do another example of a hypothesis test for proportions. This example says that a 2003 study conducted by the Environmental Protection Agency, otherwise known as the EPA, found that 6.25% of airplanes tested had confirmed coliform bacteria from the drinking water in the bathrooms and kitchens from a sample of 320 airplanes. As a benchmark comparison, 3.5% of the US population have coliform bacteria-infected drinking water. Does this present significant evidence that the drinking water on airplanes is more contaminated than drinking water in general? Use a level of significance of 0.05. This is a wonderful thing to consider. Is the water on an airplane more contaminated than drinking water in general? Let's find out. So they found that 6.25% of the airplanes tested confirmed the bacteria. And this was from a sample of 320 airplanes. As a benchmark comparison, 3.5% of the US population has contaminated drinking water. Does this present significant evidence? Significant evidence is my key word here that I'm going to do a hypothesis test. That the drinking water on airplanes is more contaminated than drinking water in general. And then we have a level of significance of 0.05. So now on the side here, I'm going to write P N X alpha, and actually I'm also going to write P hat. So for this one, I'm going to start with the thing that I know for sure. I know N is 320. That one is easy to identify. I also know that alpha is 0.05. Now I have two percentages. 6.25% of airplanes tested had confirmed coliform bacteria. As a benchmark comparison, 3.5% of the US population have coliform bacteria infested water. So because this second one says as a benchmark comparison, 3.5% of the US population, so it's a benchmark and it's specifically referring to the population, that 3.5% is my P. And then 6.25% of the airplanes that were tested is P hat. It is not X. X is the number of airplanes tested. That had the bacteria. P hat is the percentage. So in this case, we already know P hat. What we don't know is how many of the airplanes tested positive for the bacteria. If we needed to find the number of airplanes that tested positive for the bacteria, we could do that by taking the sample size and multiplying it by the P hat value. And that would tell us the X. We don't need to do that right now, but there are some cases where you need to know X and not P hat, just depending on what type of software you're using to help you with potential calculations. Some software will let you plug in P hat, some software will only let you plug in X. So if you know P hat and you don't know X, multiply N and P hat and it will tell you what X is. But let's get into this hypothesis test. So step 1 is the null and the alternative. So every hypothesis test starts with an HO and an HA. We're looking at the proportion. So we're going to have P, and then we're assuming that the proportion of infected water is 0.035. And then we want to test if the proportion is higher than the 0.035. Do the airplanes have a significantly higher amount of this bacteria compared to drinking water in general? Step 2, calculate the test statistic. So our test statistic equation is the z-score for p hat, which is p hat minus p divided by the square root of p times 1 minus p divided by n. So we don't have to calculate p hat because we know what p hat is, 0.065 minus 0.035 divided by the square root of 0.035 times 1 minus 0.035 divided by 320 airplanes. So the top is 0.03 and the bottom is 0.01027360009. As I've mentioned before, we don't want to round until we get to the end of this calculation. You can also do this all at once by putting parentheses around the top and then doing the square root on the bottom. And we get 2.920. It doesn't round on the 0. And I'm just going to double check this calculation really quickly. I want to make sure I didn't mess up. Of course, I keep messing up in my calculator. Okay, we're good. We're good. I just second guessed myself for a second, and that's okay. Just double checked. So that's our test statistic. Okay, this tells us how far away from the mean we are. And we're going to use that test statistic in step 3 to calculate our p-value, our probability value. So, optional step of drawing the curve now. And then 2.92 is kind of up here. That's our z-score. And this is a right-tailed test because it's greater than, so we're going to shade to the right. So this area represents the area for our p-value. And we're going to find that by doing 1 minus norm.s.dist 2.92, comma, true. So come on up, I'll pull up Excel. 1 equals 1 minus norm.s.dist 2.92, comma, true. This will give us our p-value, 0.00175. You could do 0.0018, but this is a really nice looking number, so I'm gonna leave it like this. All right, and now for the really important question. In our conclusion. And then after we draw our conclusion, we're gonna write out the interpretation. But the oh so important question for the conclusion, is the p-value less than the alpha? If your p is low, you reject HO. So let's find out. Is 0.00175 less than, what was our alpha? 0.05. Even though this was a right-tailed test, we want to know if the p-value is less than the alpha, because we want to know, is this significantly different? And it's significantly different if our p-value is small. So is our p-value too small to be possible? So I'm going to look a digit at a time. Those are both zeros. Those are decimal points. Those are zeros. That's a 0, and that's a 5. So my p-value is less than my alpha. My p-value is low, so I'm going to reject the null hypothesis. So coming back up here, looking at the null and alternative, this means that I had enough evidence to say that this was true, the alternative. 6.25% is far enough above 3.5% that I was able to prove what I wanted to prove. And we're going to write that in a sentence now. Oop, too far. So the sentence is going to read, we have enough evidence to support the claim that, and now I have to go back up to the problem and relook at this, that the drinking water on airplanes is more contaminated than drinking water in general. That's what I'm going to write. There we go. So we rejected the null hypothesis because we had a small p-value, and that small p-value was the evidence we were looking for. And because of that, our interpretation statement said that we did have the evidence we needed to support the claim that the drinking water on the airplanes is more contaminated than drinking water in general.